Hello, this is Mark Anderson for Kellogg Community College, and we're going to look at our first part of a statistics review test. This is going to cover just the major points of the statistics Unit 2 test. Anything in the homework is fair game for the test itself, and these kind of highlight the notes that we took so far in this section. We're going to first talk about two vocabulary words from Chapter 5, discrete variables and continuous variables. Discrete variables are items that can be counted, and continuous variables are those that are measured. So these are measured versus counted. And to get to some specific examples here, discrete variables like album sales or CD sales, or that's actually speaking to my age here, but like video game sales reported by the NPD group. Sales and also any kind of people can be measured in a survey. So if it's discrete, it can be like physically counted. Now the measured examples here are my W examples. The weight can be measured, but it's continuous since you weigh yourself at different times of the day. After exercise or after no exercise, you're going to get different results there. Also the weather, for example, is another great example of continuous variables, because the variables, it honestly changes over and over throughout the day and when you measure it. Also in Chapter 5, what we have is a problem dealing with expected values using and also finding the standard deviation when we know the x, which is our number of outcomes, and the probability of those outcomes. And this works when we have all the possibilities laid out, and I've simplified this example from the book, so it would include 100%. We just have to consider this to be 4 or more, but this is the number of cats per family. I'm going to kind of move this up just a little bit further so I can get this all on the screen here. But in terms of having 0 cats, 40% of the households have no cats, 30% have 1, 15% have 2, 10% have 3, and 5% have 4 or more. What I'm going to do is review the formula that's on your formula sheet. This is a reminder that the formula sheet that you were using during the notes, I will provide one for you during the test. You are not to bring your own. You are actually going to use mine instead. So with that in mind, the formula that you would find on your formula sheet, the mean would be the sum of the outcomes times the probability of x. And to do that, for this example, we would have our mu equal to the sum of x times p of x. So we take our x, in this case 0 cats, times 40%, and since it'll look a little weird if I put multiplied with a dot times 40, I'll use parentheses, though on the calculator you can use times. And I understand that multiplying by 0 doesn't give you anything, gives you 0, but I still want to show you what the entire function should look like as you type it in as one giant string on your calculator. And then there's 3 times 0.10, and then there's 4 times 0.05. So this is an example of this is our x and this is our p of x, the x and p of x in the table. It'll always be given to you like that. The first column or the first row would be x, the second row will be p of x, and there you have your equation. If you type this in carefully, I understand that this does make 0, but the rest of these make a total of the mean, which is 1.1. So what's important about knowing this answer for this part of the problem here is that we need this answer to find the standard deviation. So we now know that the average cat per family is about just a little bit over 1. But I kind of want to know the standard deviation of that to see if it's, to see what the normal, range of cats would be. Since the average is 1.1, what's the plus or minus on that for, around 38%, or excuse me, 68% of the population, or one standard deviation above, one standard deviation below. So what we have is this a little bit more complicated formula for the standard deviation, and I'll have to move this down a little bit to get it into the screen here. The formula for the standard deviation is going to be, and I'll use lowercase sigma here, is going to be the square root of the sum of, in this case, x squared times p of x. And then when you're done with that, you have to subtract that answer that you got here, which is 1.1. That was your mu. You got to subtract that squared from this set of sum. And what I would suggest to do is start without the square root. So we're really going to talk about the variation here. We're going to get to our standard deviation answer eventually, but we'll start by not using the square root. So we're going to go 0 squared times 0.40. Understand, I do know that this is going to make 0, but to show you the pattern, it's going to go 1 squared times 30%. And yeah, I could remove those zeros too, but you know, I'm just trying to show you how the pattern would work with the above problem. 15%, and then 3 squared times 10%, and then 4 squared times 5%. And then we're going to subtract the 1.1 squared. Now if we're careful to type all of that in on our calculator, what we then have is our variance, not the standard deviation, but the variance is 1.39. And then we take the square root of that to get to our answer, because the square root of the variance is the standard deviation. So we take the square root of the variance, and the square root of the variance is going to be our standard deviation of 1.17. So our answer is there's 1.1 cats per family, give or take about the same amount, 1.1. So we can say that most normal households have between 0-ish, I mean it's a little bit less than 0 if you subtract that from your 1.1, but we can just say realistically a normal household will have 0 to 2 cats. I think it would be more abnormal to go beyond that, because that's further than one standard deviation away from the norm. And this ends the first of I believe 6 parts or 5 parts of this video here. Thank you for watching today, and I will see you in the next video.